Alright, today we're going to talk about a couple of different protocols here based off some common ports that you should know if you're working in technology. The first one we're going to talk about is called SSH or Secure Shell. And so a little bit of background on SSH. It was designed as a replacement for another protocol called Telnet, and Telnet was designed to be able to run commands, interact with other systems without physically being there. So it allowed you to kind of remotely manage that server, and this worked for a while until kind of the expansion of the internet. More and more people started to get online, and people started to realize that Telnet was operating in clear text, which would then allow someone to, if they were sniffing your network traffic, capture plain text usernames, plain text passwords, see all the commands you were running. So in 1995, a new protocol got developed called SSH. And as we already said, that stood for Secure Shell. And what that means is it is similar to Telnet, only it creates an encrypted tunnel between the client and server. So we can pretend I've got my server set up here, and we'll just say that's in, I don't know, Tokyo for this example. So I don't have access to this physical machine, but I need to get on, maybe check my web server, add a new user for FTP access, something of that extent. So we're going to use a tool called Putty, which is a free tool. There we go. And then we're going to connect 192.168.0.75 over the default SSH port, which is port 22. And we're going to hit open. So the first thing we're going to see is this little alert box that pops up that says this server's host key is not cached in the registry. You have no guarantee that this server is the computer you think it is. So right off the bat it tells you, hey, we see you're trying to make a connection to a server. We don't know if this server is who it says it is. Would you like to cache this key so we don't warn you about it in the future? And then it's got the RSA key right below it. This server's RSA2 key fingerprint is, and then if you trust this host, hit yes. Otherwise, kind of ignore the error message. We can hit no, or we can cancel it, which will close our session. I know that this is the server I'm connecting to, so I'm going to hit yes. And now what that means is, if someone were to hijack this server and change that SSH key, next time I try to SSH into that box, I'll get that same message that says, hey, wait a minute, this key isn't the same one that we cached in the registry. There's a possibility that this isn't the computer you're trying to connect to. Otherwise, that prompt won't show up again. As long as that key doesn't change, we won't get that prompt again for this server. So we're going to log in here. And it looks like let me just double check this. There we go. That's a problem. Sorry about this. Alright. Basically, I didn't allow the user Nate to be able to SSH into this box. So we're just gonna reconnect here. And now that we already have that key stored or cached on our client machine, we shouldn't get a prompt saying, are you sure you want to connect? It should just automatically connect. There it goes. There we go. Alright. So now this is kind of like the Windows command prompt black text. You can change your preferences in the PuTTY configuration. So now we can check to see where we are on the server and where my home directory. We can do uptime, see how long our server's been running. We can, check on our web server, see how that's going. And all of this, if I wanted to do a Wireshark capture here, let's just type some commands here. Get that all done. Then we'll stop that. If we filter by protocol, we should be able to TCP. Should be able to see all of these SSH packets that our computers sent out. So go ahead and click on one, and we look at the SSH protocol. There's that packet. So if this was Telnet, this would say whatever the command we were typing in. So if we did a user add or passwd to change our password, all this would show up in plain text. Whereas now it's encrypted with SSH, and you just see this jumbled mess here we got going on. And the SSH can be configured two ways. The first way, which I have set up for this demonstration, is you go into your SSH config, your SSH server config, and then you just allow the users at the bottom. And what that means is they'll log in with the username, password, and then that will grant them access to the box. This is susceptible to brute forcing. If an attacker, has a word list with, a couple 100 million passwords, and they know your username, they can just sit there and just pound out a script, hitting that server, hundreds of thousands of times until they try to get in, if they can get in. Another method, a little bit more secure, is called SSH keys. And what that does is it creates a key pairing for your user account to the server. So when we added that server earlier, we seen that's that server key. That's the public server key. Well, when we set up a key for our user, that would become a private key. And so if I used that key to connect to this, local server here, that key would say, hey, this is who I am. I know that's who you are. Let me in. And this is fine and dandy as long as you never lose your key, or no one steals your key. Because with your key, they can get into the server without a password. Now, that being said, when you generate that key, you have the option of being prompted a password in order to use the key. So if we loaded up PuTTY and we were using a key, it would prompt us for that password that we set to be able to use the key. And that's the most secure method of using SSH. So we're just going to exit out of our server. And again, the default port for SSH is 22. There we go. What ports and protocols are we listening for? So we're listening on port 22, which is the default. And then there's the host keys information. We're not going to dig through this config file. But it is there if you want to read it. And that's typically under Debian and Ubuntu. That's going to be under etc ssh sshd_config. And if you want to try this at home to install an SSH server, all you have to do is run sudo apt get install SSH. Oh, geez, can't type today. And then if you just want it to install without any user configuration, you can just do a -y, which means, yes, I know that's the package I want to install. Go ahead and install it. So another protocol we're going to be looking at here is called FTP. And what FTP is stands for File Transfer Protocol. So if the company you work for has a website, typically those websites aren't housed on the same network that you would go to the office for. They usually go through a third party hosting platform like GoDaddy, HostGator, a number of different website vendors that will host your website and then give you access to upload your own content. And one of the easiest ways to upload your website is to push it to FTP. Now, the problem with FTP, just like Telnet, is that it's an older protocol, which means it sends plain text again. So when you're authenticating with the server, you're sending, username, Nate, password, my password in plain text. So if someone's sniffing your network traffic, they're going to be able to see all of that, and they'll be able to impersonate you. They have your credentials. They have access. So what happened is FTP kind of got split into two different sections called FTPS and SFTP. FTPS, which is File Transfer Protocol Secure, has that secure at the end of it, kind of like HTTP. When it gets that SSL cert at the top, that usually means it's safe. Your network traffic's encrypted with that S. It works the same with FTP. So if you see that FTPS connection, that means that your network traffic is encrypted. And then the other side of that is SFTP, or Secure File Transfer Protocol. And what this does is it actually creates an SSH session like we just did here through PuTTY. It creates that SSH session, and then it allows you to use FTP over that SSH tunnel. So the traffic you're sending isn't encrypted in itself, but it's being sent over an encrypted tunnel to the server. So the tunnel's encrypted, but the network traffic, or the information, I should say, isn't encrypted. And we can do that here with another tool called WinSCP. And this is what a lot of web developers use. They'll put in their website or their host name here, connect to it, and then, as you'll see here in a second, you'll have two columns. One column on your machine, and then the server side machine, and you can literally just drag and drop in real time, and that'll push those files to the server. So what we have selected by default is Secure File Transfer Protocol. And as you can see, that's running over port 22, which is SSH. So if we connect to our server, we can store those at the login level there. Now when we hit login, I believe since we've already cached the server key, it's not going to prompt us. If it's the first time that you connect to your server, it should prompt you for that registry key again. Oh, nope, it does. Sweet. Alright, so continue using an unknown server and its host key to a cache. Again, we've already connected to this. I know that this is the server I want to connect to. I just set it up. Highly unlikely anybody's had access to it. So we're going to say yes. And there we go. So I'm just going to go here, go into our new folder, and you can see the home directory by default when we enabled FTP on this server goes to our home. So if we wanted to pull down a document, so say somebody said, yeah, we uploaded this to your website, go ahead and take a look at it. You can use WinSCP to connect to that server, open up where those uploads went, so an important document, we can go ahead and drag that over and then just open it on our machine. Important stuff, right? Good deal. Same thing goes, I don't know if I don't think I set up write permissions on this. Oh yeah, nice, I did. Alright, so I just created that new text document and enabled it test.txt, and we can see it's in my home directory. So on the server, let's go find that. Alright, and there we go. Test.txt uploaded 1 minute ago. We can see we have the default rights because I was logged in. I'm logged in on WinSCP as Nate, so I'm given the rights to that file. So let's just do a quick cat, and there we see it. Probably should have done a new line there. But you can see that test. Alternatively, we can do open it in a text editor, and there we go. There's the file. Now, this was over secure FTP. FTP, the connection and the I want to say smoothness of it doesn't change much. So if we disconnect and we reconnect to the server, and instead we just use FTP, WinSCP will actually ask you, is there encryption set up? And if this is a default server installation, there's not going to be any encryption set up. So they offer TLS explicit, SSL explicit, and those are all things you can change in the FTP server installation config file, which I believe is in etc vsftp. Yep, and that server config file is in etc vsftpd.conf. So you should be able to set those that type there if you wanted to use, and that's going to be using FTPS. And we've already connected with SFTP. This will be using FTPS because it's sending the information encrypted, right? The method we just used, we were sending non-encrypted information over an encrypted tunnel. So they're both ways are still encrypting the data, just different ways of doing it. So we're going to log in. And actually, I wonder if we can just... Let's try this. Let's see if we can capture this in Wireshark here, this login. Oh, I forgot the 168. That's not going to work. I don't think I said this already, but the default port number for an FTP connection is 21. SSH is 22. FTP will actually use ports 20 and 21, but it uses port 21 for basically storing the session for controlling what's going on. So there we go. So now we're on the server with just a plain FTP connection. So if we stop this, capture, sort by protocol, there we go, response, yep. So we can see, and there's my default password there for this server. Sent over plain text, username was Nate, password was monkey. So now any attacker that was eavesdropping on that communication can then use that information to log into my server. So, you know, definitely use SFTP or FTPS, either or. I use SFTP. It's just a lot more easier. It's just a lot easier if you already have SSH set up to route your traffic through that tunnel. But anyway, I hope you learned something from this, and thanks for stopping by.